Lecture we will get started. SOM. SOM, the full form of SOM, strength of material. In this lecture we will start SOM and chapter of first unit, stress and strain. Firstly, strength. What do you mean by strength? That is calculate how much could be load carrying capacity of certain material. Any load we will get a start. Any load carrying capacity of certain material. Any rod. Suppose rod we will capability of load. Then we capacity of material do those are used in engineering applications. Engineering applications such as like this applications is bridge, boat, note and room etc. What do you mean by stress? It is defined as the internal resistance to the external load, or it is define internal resistance to the external load, or other definitions is stress. It is defined as the ratio of internal load to the cross section area. It is denoted by sigma. Mathematically, stress is sigma external load to the area by a. It is load is denoted by P and area is denoted by A. In this rod, suppose a rod in this cross section area is A and load is P, and in this rod we will get applied a axial load in a straight member A and B. A and B, they will divided in this rod load, and we will get rod R, and will load and R in this area is same as A. Stress is denoted by sigma and is equal to the load by area. In this unit, load that means force is Newton and area is equal to meter square. In this unit, Newton per meter square, 1 Newton per meter square we will equal to the 1 Pascal. The how to sum identify the prefix 1 Pascal is equal to 1 Newton per meter. 1 kilopascal, you will get to you 1 Pascal is equal to the 1 Newton per meter square. 1 kilopascal, kilo that means kilo is equal to 10 to the power 3. I say 1 Pascal is equal to 1 Newton per meter square, like Newton per meter square. 1 megapascal is equal to mega is equal to 10 to the power 6 Newton per meter square. 1 gigapascal is equal to 10 to the power 9 Newton per meter square. You will get kilo, that means 10 to the power 3, and mega is equal to the 10 to the power 6, and giga is equal to 10 to the power 9. And also remember one things, 1 Pascal is equal to 1 Newton per meter square. You will know that 1 Newton meter square is equal to 10 to the power 3 is equal to is 1 to the power 3 का whole square mm square. Like that 1 meter is equal to the 10 to the power mm square. Like this meter square 10 to the power 3 whole square mm square. Newton 10 to the power 3 2 ja 6 10 to the power 6 mm square. Then 10 to the power minus 6 Newton per mm square, per mm square. 1 Pascal is equal to 10 to the power minus 6 Newton per mm square. 1 Pascal is equal to 10 to the power 3 Newton per meter. You will know that 10 to the power 3 Newton per 1 meter is equal to 10 to the power 3 mm square 10 to the power 3 का whole square mm square 10 to the power 3 into 10 to the 3 2 just 6 10 to the power 6 power is multiplied mm square 10 to the power 3 like that cancel 10 to the power minus 3 Newton per mm square. We will get, remember 1 megapascal is equal to mega is equal to 10 to the power 6 Newton per mm square, because Pascal is equal to Newton per mm square, and mega you will get, remember 10 to the power 6 Newton per meter square. 10 to the power 6 Newton is Newton, m1 meter square is equal to 10 to the power 3 mm square, because a square is then a square 10 to the power 3, 1 megapascal is equal to 1 10 to the power 3 to the 6 and 3 to the 6 cancel. Newton per mm. 1 megapascal is equal to the 1 Newton per mm square, millimeter square, that like that. 1 gigapascal, you will know that giga is equal to 10 to the power 9. A pascal is equal to the Newton per meter square. 10 to the power 9 Newton per meter square, 10 to the power 9 Newton. You will know that 1 meter is equal to 10 to the power 3 mm square, because of a square meter square 10 to the power 3 whole square mm square, 10 to the power 9 and 3 to the 6 mm square. Then we will get 10 to the power 3 and Newton per meter mm square. 1 gigapascal is 10 to the power 3 and Newton per mm square. Stress can be classified into three types: direct stress, indirect stress, and combined stress. We will know that direct stresses. Direct stresses defined. Direct stresses which are developed due to the applied forces, those are further classified by normal stress and shear. I know that direct stresses we develop the normal stresses and shear stresses. We will apply the developed due to applied force. Yani like that, any rod, suppose a rod, we will apply the force, we will develop those further classified normal stress and shear stress. Normal stress will be classified in compressive and tensile stresses. We will know that compressive stresses will a straight member and axial load, normal and compressive. Normal stresses. Indirect stresses which are developed due to the bending and torsional. Bending, that means bending comes to tensile, compressive and shear stresses developed in this body. Bending, you remember that tensile, compressive and shear stress to develop in these bodies. And torsion causes shear stresses in the body. Combined stress like the which are combined, like that combined name of the definitions. Combined combined stresses like that which are combined, direct or indirect stresses. Combined which are combined, direct and indirect. We will know that direct stresses, normal stresses and shear stresses. Normal stresses are divided, can be classified into two types: tensile and compressive stresses. And shear stresses, indirect stresses. Indirect, you will know get bending and torsional development on this body. Torsional type like this bending. Bending means shear stress and tensile stress and compressive stress can be developed in this body. And torsional stress like that means shear stress in the body. We will get. Thank you for watching these videos, and please share, subscribe and these videos.